Okay, so hello guys. So here's the next question for the problem of the day in Leetcode, that is maximum candies allocated to k children. Okay, so what the question is, basically we have been given three number of candies, that is 5, 8, 6. Okay, you can say that is jar. Okay, three jars which have candies, that is 5, 8 and 6. Okay, that will simply contain jars, and k is the basically number of children, and we have to give all the children equals candies equal. Okay, and we can simply give equal candies from one pile also. Okay, but we don't have to merge piles. Okay, piles are basically jars. Okay, so this is basically the question. You can read the question more in detail in the Leetcode. Let's just understand the question detail. Okay, in detail. So I have made this jar, that is for this. I'm taking this example. Okay. So in first jar we have 5, and second 8. You can see, and third we have 6. So we have total number of children, that is 3. Okay. So if I write, let's just C1, that is children 1, and C2, that is children 2. Okay, and C3, that is children child third. Okay, so we have written here the all number of child. I will explain you the question in detail. Okay, so what we have to do, just first understand, we have to basically give children all the children equal candies. Okay, so simply you will see the, and we can do we can take basically candies from every basically jar, or we can give candies from one jar also. Okay, but we don't have to merge the jar to give the candies to this basically these children. Okay, so if you think, we can give one candies to all the children from all the jars. Okay, so that's also valid. Or we can give one candies from one jar to all the children, that's also valid. So you got it. Okay, but we don't have to merge them. Okay, like if there was 0 candies and here was 2, then simply we can merge 1, 2 here, and we can say one candies. No, that's not. We can give only 2 from here. Okay, so you got the question what we have to do. So in this question, one thing is that, so if you are thinking that then we can give one candies to everyone and we can return, no, we have to return the maximum number of candies that can a child get. Okay, so 1 is the minimum. Okay, you can think of it. Okay, so if you see here, what is the maximum candies we can give? If you think here, all the common we have 5. Okay, so we can simply give 5 candies. That if we take here, that is 5 candies, we can simply give here 5 candies first children, and then we can take 5 candies from here, and we can simply give 5 candies to here, and we can simply take 5 candies from here, and we can simply give 5 candies to third children, and so the output is also 5. If just think, if the candies were only basically 6. Okay, if we have to give candies 6 or basically 3, no, basically let's just take it 3. Okay, so we can simply give 3 candies like here. Okay, let's just think, if we are giving only 3 candies to children, then simply we can simply give 3 candies from basically 6 contains 3 candies, total number of 6 candies. Okay, and we can give 3 candies to one children and remaining 3 candies to another children. So you got one thing, that if we are basically getting the number of candies, then we are simply basically what we are doing, we can divide the number of candies to the basically total number of candies in one jar, and we can simply get the total number of children that can be basically get. Okay, like here it has total 6, and if we are giving 3, then the total number of candies, that basically total number of children that can be fulfilled are 2. Okay, so mummy, okay, so total number of children are getting fulfilled. Okay, So what we have to do, you got the basic idea of basically what we have to do. Okay, so you can also take the example of 5 here. Okay, if you divide all the basically jar with 5, okay, like candies with either here, if we divide this 5 with first jar, that contains 5 candies, then simply if we are basically giving 5 candies to every children, then simply we will divide it. So 5 will divide, then we will get 1 basically children can get only. Okay, and here also 8 is divided by 5, then only 1 children can be fulfilled. Okay, here also 6 is divided by 5, then only 1 children can be fulfilled with 5 candies. Okay, so you got the thing what we are going to use. So simply our approach is, if we start from 0 to last number of candies, that is maximum number of candies, and check for every candies, and we will divide the every candies with this basically these jars, whole jars. Okay, and we will get basically a total number of children can be fulfilled. Okay, so and total number of children is k. Okay, so we will basically always use maximum value. Basically we will iterate. Okay, and whenever the value basically is equals to k or smaller than k, we will basically return. So you got this, because if you will take to one if you will take 1 or 2 candies, then the values would be simply just like here, just first dry run. Okay, so we will choose from 0 to 8. Okay, so we will, let's check 1. Okay, so 1 we will divide it from here, so all the number would be 5. Okay, so but we have basically 3 children, so simply it is not the answer. Okay, then 2 is divided by, then here 2. Okay, that is 2 children, and here that is 4. 2 plus 4 6. Okay, so simply it is getting bigger than the k, then simply we are not the answer. So that's the approach, and every time a number will check, we will divide and we'll check if the number basically all the children that are fulfilled are greater than, or basically then we will have to not return. They should be simply smaller than or equals to k. Okay, so you got the thing. Okay, so if you think the time complexity of this brute force will be simply n square, because we will iterate here also, and we will then basically for checking in every basically jar or basically candies array, there also take big of n. Okay, so it simply got big of n square. So to reduce it, we are using binary search. Okay, on this, like 0s to 8, we will use binary search. Okay, first we will check for 4, and then again move our according to binary search. So you got the thing now, basically how binary search works. Okay, so what we are going to do is, let's just make. Okay, so here's the, I have made the basically array, and we have also pointed low and high and mid. Okay, because we are using binary search. Okay, so let's just see how we are basically going to work. So mid would be simply at 4. Okay, first, then we will simply check for 4. Okay, so 4 we will first divide by this every basically number of candy by 4. Okay, so simply it will give simply 1, and 8 by 4 will be simply 2, and here you can see that it will simply give 6 divided by 4 equals to 1, and you are seeing that it's a valid answer, because here the number of basically children are greater than k. Okay, k was 3 and here it is 4, so simply it is the valid answer, it can be fulfilled. So simply what we will do, we will move this low to at the mid position, then we will again calculate the here, so the mid would be simply at 6. So then we will check for 6, so it will not be give valid answer, because it will simply give lower than k, that is 6. 5 by 6 would be simply 0, and here that is simply 1, and here 1, that is 2. So at 6 the total number of children that can fed are 2, so it will simply lower than k. So we will not we will simply move high. Okay, so high would be simply at mid minus 1, that is at 5. So the mid would be simply like if you calculate, then simply the mid would be okay, so mid is here. Okay, so the mid would be here. So so simply mid would be here, and at 5 it will simply give equals to 3. Okay, that 5 by 5 is 1 and 5 by 4 is, oh sorry, 8 by 5 is 1 and 6 by 5 is also 1. So simply at 5 the answer would be come and we will get the answer. Okay, so simply it will return the value, and at last the simple loop will exit. You know the binary search loop how exists. Low is always high. Whenever the low equals to high, we will simply exit the loop. So this is how the whole approach will work. Okay, so you got the thing. Okay, so we will see the code in. Okay, so you can see the code also. Okay, here I have opened the Leetcode. So what we have done, first we have initialized the max candy, and then we would simply get the max candy by this max function. Okay, then we will simply take the left and right, and we will simply use the while loop, that is simply binary search, and we will simply for every mid we will check for this can candy is valid. Okay, so and if it is valid, then we will move left to mid, and then if it is not, then right to mid. Okay, so simply we return left. So you can simply see the function also. We have taken max children. Okay, so simply every time we will divide by candies I by mid. Okay, the value that we have tell. Okay, so simply by division we will get the number of children that basically that number of candies can fulfill. Okay, so simply we will add them all. If that is basically greater than or equals to k, then simply we will return true. If it is not, then we will false. Okay, so you can submit it. So yeah, it's fine. You can also see like basically its time complexity would be n log n, because log n simply takes this binary search and n is taking this loop. Okay, so you can see yes, n log n max. Okay, so that's the